Alright guys, so let's go over properties of water today. Remember we're in unit biochemistry. Make sure that you fill in your notes as we go along. Tear out and glue your note page on your notebook, page 20. Alright, so properties of water. What makes water so special? Water is a molecule made up of H2O. Is made up of 3 atoms, 1 oxygen and 2 hydrogen. So what makes water so special? Water is polar. Basically, it's acting like a magnet. We have a positive side and a negative side. The oxygen end acts negative, while the hydrogen end acts positive. So this causes the water to be polar, or like a magnet. Here you can see on the illustration that we have 2 hydrogen atoms that act positive, and we have a large oxygen atom, and so therefore we have a negative side. So we have a positive and a negative side, so just like a magnet. Hydrogen bonds exist between water molecules. So we have a negative oxygen end of one water molecule is attracted to the positive hydrogen end of another water molecule to form a hydrogen bond. So in the little animation you can see the hydrogen bond forming between the negative oxygen end and the positive hydrogen end. The oxygen is red, the hydrogen is white. So what are the properties of water? Properties of water, we're going to talk about cohesion, adhesion, high specific heat, and less dense as a solid. So cohesion, the attraction between particles of the same substance. Water is attracted to itself. The results in surface tension, a measure of the strength of water's surface. So you're going to perform the lab that you're seeing in the animation, where you're going to take a paper clip, and if you place it oh so gently on the surface of the water, that paperclip should float. Because the water molecules are cohering to each other, they're attracted to itself, so it's wanting to prevent that paperclip from going through its surface. Cohesion also helps insects walk across water, and I'm sure most of us have seen these little water bugs that basically can glide across water. But how is it helpful to people? Think about that question. Adhesion. It's attraction between 2 different substances. Water will make hydrogen bonds with other surfaces such as glass, soil, plant tissue, and cotton. Capillary action. Water molecules will tow each other along when in a glass tube. So think about when you put water in a graduated cylinder. The water will go up the sides of the graduated cylinder. They would adhere to the sides, leaving that meniscus, and we tell you to measure the bottom of the meniscus to get your most accurate reading. It's also, if you have a water droplet on the table and you put your paper towel right next to it, and it will then absorb or adhere the water to the paper towel. Adhesion causes capillary action, which gives water the ability to climb structures. So the roots, obviously we know, are at the base or the bottom of the plant. The roots will then absorb the water, and through capillary action, the water is transported through the xylem throughout the plant, from the base of the plant to the top of the plant through capillary action. High specific heat. The amount of heat needed to raise or lower 1 gram of water or a substance 1 degrees Celsius. Water resists temperature change. It doesn't like to change, both for heating and cooling, which is one of the reasons why boiling water takes a long time. You need a high heat. So would you rather walk on sand or in water on a beach on a hot summer day? And then at night, which would be warmer, the water or the sand, and then why? Water is less dense as a solid, which is ice and which is water. So if you look at the 2 illustrations, water is less dense, meaning it is almost, which is the reason why ice will float on water. So here we have a very dense structure. Here we have a less dense. You can see the holes through it. So this would be our ice. This would be our water. So let's talk about solutions and suspensions just for a little bit. And you're going to watch another video later on about the different types of mixtures and solutions. Water is usually part of a mixture. There are two types of mixtures. You have a solution and a suspension. Solution is the substance that dissolves in liquid. So like Kool-Aid would be a solution. Suspension is substance suspends in liquid. So we're having something floating. It could be something like a bowl of cereal or ice in your iced tea. Something is floating or suspended in that liquid. Water is the solvent. Salt is the solute, and I think the bottom portion just got cut off. And then salt water is the solution. Okay, so water is the solvent, salt is the solute, our solution would be salt water. Suspensions, substance that does or do not dissolve but separate pieces. Sorry, I just totally messed that up. Substances that don't dissolve but separate into tiny pieces. So that would be our bowl of cereal. Acids, bases, and pH. One water molecule is made up of two ions, a positive hydrogen and a hydroxide ion, which is OH, and that is a negative. So we have H2O yields to have a hydrogen ion, which is an acid, and a hydroxide ion, which is a base. Acids and bases. An acid is a solution with lots of hydrogen ions, so the pH 0 up to 7 is an acid or acidic. The base is a solution with lots of hydroxide ions, so the pH above 7 through 14 is basic or alkaline. Here's our pH scale for our acids. The acids are usually represented with a red color. Indicates the percent of hydrogen ions. Our pH scale again ranges from 0 to 14. Acids are from 0 to 7. pH of 7 is neutral. So pure water would be neutral. The human blood is just above 7. Milk is about a 6.5. Normal rainfall has a pH of 6. If it's acid rain, it has a pH of about 4.5. Tomato juice, pH of 4. Lemon juice, pH of 2.5. And the stomach acid, hydrochloric acid, has a pH of 1.5. So that's very acidic. So the pH scale for bases indicates the percent of hydroxide ions. Remember, our pH scale ranges from 0 to 14. pH of 7 is neutral, so anything above 7 is considered a base or alkaline. So seawater is about an 8.5. Most soaps that you use are about a 10. Bleach, about a 12.5. Oven cleaner, 13.5. So we have most soaps are at a pH of 10. Baby soaps are actually at a pH of 7, so you could get it in your eyes and it won't burn. So they actually had to put an acid into the alkaline, the base basically solution to create that neutral baby, like Johnson & Johnson baby shampoo, so just in case you get it in your eyes, it wouldn't burn. Then we have buffers. Weak acids or bases that react with strong acids or bases to prevent sharp sudden changes in pH, the neutralization. Just like what I told you with what Johnson & Johnson does with the shampoo, they have to put a buffer in that to basically neutralize, to bring it to around a 7, so that way when the shampoo gets in your eyes, it doesn't burn. Adult shampoos don't have that because they assume that most adults will know to close their eyes when using shampoo. So a weak acid would be vinegar, a weak base would be like Dawn dishwashing soap. Buffers are produced naturally by the body to maintain homeostasis. Homeostasis is that balance between the internal and external. We want to keep everything in nice and basically running perfectly so we don't get sick. Human biology and the pH. Your blood maintains a pH of 7.35 to 7.45. So it has a slight alkaline or basic structure to it. The balance is maintained by buffers in the blood, breathing, and urinating, because we're constantly getting rid of waste products and exchanging it for new, healthy, or oxygen, or oxygenated blood, and we're adding in water, getting rid of the carbon dioxide.